Number 27, if x plus 2y times dy over dx is equal to 2x minus y, what is the value of double prime, right? At point 3 is equal to 3 and 0. So first, let's go ahead and solve for the dy over dx so we can take derivative of that. So dy over dx would be 2x minus y divided by x plus 2y, right? I just divided by x plus 2y on both sides, like this. Now, we're going to go ahead and take the derivative of that thing, right? So first of all, you guys can go ahead and do the quotient rule if you would like, but I really don't like quotient rule. I just like chain rules a lot better. So I'm going to call that 2x minus y times x plus 2y to the power of -1. I like to solve it this way. So let's go ahead and take the derivative. So that's going to be, take the derivative of the first, which is 2 minus dy over dx times the x plus 2y to the -1 plus 2x minus y times, here we go, -1 x plus 2y -2 times, we have 1 plus 2 dy over dx. I understand this looks pretty nasty, but it's not going to be as bad as it looks because all you have to do is simply plug in all the freaking values once we have this, right? So let me just rewrite that into something that looks better, perhaps. 2 minus dy over dx all over x plus 2y plus, what do we have here? We have 2x minus y times 1 plus 2 dy over dx all over x plus 2y squared, and I realize it should be minus because of the negative. Okay, so this is going to be what it is, right? So now we're going to go ahead and punch in the 3, 0, that point that we have here. And then also, I want everybody to understand, you have this dy over dx, right? So let's go ahead and figure out what dy over dx also better be as well. So that's going to be 2 times 3 minus 0 over 3 plus 2 times 0. Where did I get that? Once again, I'm getting that point from the given point, right? So I'm just simply substituting the xy with 3 and 0. So if you guys do all this, this is what it's going to look. Oh, so that's going to be, let me finish this. That'll be 6 over 3, which is going to be a 2. So let's go ahead and plug everything in. So dy over dx is a 2. And then we have x is equal to 3, y 0. So 3 and then 0. Sorry, I'm just going to kind of write all these and then I'll fill the rest so you guys can see the color coordination. Okay, so that's equal to 2 minus that over plus 2 times that, and then 2 times that, and then 1 plus 2 times that, and then plus, whoops, it's not enough space. So plus 2 times y, which is 0. So hopefully everybody sees what I'm doing. Let me go ahead and show you. I just literally plugged in wherever dy over dx is, all 2, because that's what it is, right? So that's where I have these. And then the y's, I replace with all the zeros, as you guys can see. And then obviously the x, I replace with all the 3's, as you guys can see. So that's kind of what's going on, right? So you just have to not F up the signs, and that's what it is. So here we go. That's just going to be 0 over 3. That just goes away. And then what? Minus. Minus. What do we have? We have 6 times, that'll be a 5 all over. That's going to be 3 squared, which is a 9, right? So you can actually cancel 3's. So that's going to be a 2. That's going to be a 3. So that's going to be negative 10 over 3. That's why answer choice A would be correct. So this question looks deceivingly hard just because there's a lot of like terms that you have to keep up with, but it's really nothing but just taking the double derivative. But you just got to make sure you don't F up. Whether you're using the technique that I do, you know, just put it to the power of -1 and then use the chain rule, or you want to just go ahead and use a quotient rule, or you want to use that whole like the U and V substitution thing. Whatever works for you. But I guess technically the UV substitution is basically doing, you know, kind of like that quotient rule. Yeah. Or chain or whatever. Yeah, so just, you know, don't F up the orders and you're going to be fine.